Hackers and painters, big ideas from the computer age. Spark 1. The creative nature of programming. Most people who don't code think programming is boring and analytical. But if you're a programmer, you know it's actually very creative, like painting. Good programmers, like artists, focus on making great things. The possibilities are almost endless. Programming isn't the only thing non-programmers get wrong about coders. Yes, programmers might dress unfashionably or act awkward in social situations. But this is mostly because they're smart people who don't care much about social rules. This rebellious spirit is what makes them so good at programming. It's a mindset that could help anyone come up with new ideas. Paul Graham, the author of Hackers and Painters, knows this firsthand. He's a British programmer and venture capitalist who co-founded a startup called ViaWeb. In 1998, Yahoo bought ViaWeb, which later became Yahoo Store. Graham's experiences as both a programmer and an entrepreneur give him unique insights into the world of coding and startups. Spark 2. Nerds, fashion, and morals. What do fashion and morals have in common? At first glance, not much. But both are tied to a specific time and place. Fashion is obviously linked to a particular time. Look at photos from the 1990s, and you'll see how much tastes have changed. And if you look at images from other countries, like Japan, you might be surprised by what's in fashion there. Surprisingly, morals are just as temporary and location-dependent. Moral fashions affect a whole range of issues, including how we should treat others and what values we hold dear. An extreme example is how the moral compass of many Germans during World War II was very different from the values of modern Germans today. So, both clothing fashions and moral fashions are always changing. Can you think of any group in society that doesn't notice these changes? Of course, nerds. These are smart people who aren't socially skilled and don't try to fit in with others. Nerds use their time and energy to get smarter without worrying about following fashionable rules. This might be most obvious when someone wears the same neon denim jacket every day for 5 years, but it also applies to moral fashions. As a result, nerds usually aren't very popular among their peers, especially in high school. To be voted prom king or queen, a student usually has to be in tune with current moral and clothing fashions. But after high school, in the real world, where being fashionable doesn't matter much anymore, nerds often do just fine. Spark 3. Hackers as artists. When you hear the word hacker, what do you think of? Most people probably imagine a cold, calculating person who illegally breaks into computers through tedious, analytical work. Now, think about an artist, like a painter. You've probably imagined an inspired genius pouring their soul onto a canvas. Let's clear up some misconceptions. First, in the computer world, hacker actually means an outstanding programmer who can do almost anything, not necessarily a criminal. What's more, hacking requires a very creative mind, more like a painter's than a mathematician's. In fact, hackers and painters are similar because they both solve problems by creating concepts rather than just implementing them. For example, Graham was originally taught to work on computer code on paper until it was perfect, and only then transfer the code to a computer. But he found that an artistic approach worked much better. He would just start writing code and solve problems as they came up, much like a painter might start sketching and work from there, rather than perfectly planning everything beforehand. Another similarity is that both hackers and painters produce work with abstract value, which is hard to measure through things like tests or media attention. The only way to measure the value of such work is by how well people like it. For software, this depends on how well it pleases the user by meeting their needs. For art, it depends on how well the work pleases the audience. Graham came to understand these similarities when he went to art school after getting a degree in computer science. He found both fields had more in common than differences, because both aim at the same basic goal, making good things. Spark 4. The rebellious nature of hackers. You might think that successful computer programming requires strictly following rules and conventions. After all, not doing so would result in a bunch of errors, right? Actually, becoming a hacker often means breaking some rules. Just like in any other job, you can only learn to hack by looking at the work of those who came before you. And if you want to take a really close look, you might have to bend and break some laws, as the work you're interested in might be protected by intellectual property rights. Hackers are curious about the latest technologies, like cutting-edge software. To study it, they might have to break into someone else's computer. These actions are often illegal. So hackers are seen as criminals, even though they're usually breaking the law out of curiosity, not to steal anything. When computer break-ins were first classified as a crime, the Federal Bureau of Investigation, FBI, had trouble with these cases. Often, a hacker's main motive was simple intellectual curiosity. For the FBI, this was a completely new kind of criminal motive. You might think hackers should just follow the law, but their rebellious nature is what makes them so good at what they do. Why? Because being rebellious means questioning authority, whether it's the government or experts in your field. And questioning established ideas is the only way to come up with innovative ones, which is essential for good programming. Most hackers are nerds, smart people who don't really care about social conventions. This makes them especially good at challenging everything and then improving on it. Spark 5. Startups as a path to wealth. Many people dream of starting a company based on a great idea they've had. But if you're a good programmer, you really should go for it and start your own company. Why? Because launching a startup is one of the fastest ways to become rich. When working for a big corporation, your wage won't increase much no matter how hard you work. But if you start a startup, you'll have to work very hard, but at least every hour of work you put in will make it more likely that your company will succeed and you'll get a big payout. This is what happened to Graham. He and his startup's two co-founders worked long hours on their online shopping application called ViaWeb and eventually sold it for millions. Some might argue that this is the wrong goal, and that concentrating wealth in the hands of the rich is a mistake. But actually, concentrating wealth is not only fair, it's good for everyone. Why? Because wealth is not the same as money. Wealth consists of the things that people want, while money is only the medium of exchange that people trade for wealth. With this distinction in mind, it's clear that wealth can be created by anyone without reducing the wealth of others. For example, if you own a classic car and fix it up in your spare time, you're creating new wealth without taking it away from anyone else. This means wealth is not limited, so the rich aren't hogging it. Also, isn't it possible that the richest individuals, like CEOs and professional athletes, really have worked harder and more productively than others, so they deserve their wealth? For instance, if you have to work 10 times harder in your startup than the average corporate employee, isn't it fair that you earn 10 times the income? Especially when, in doing so, you'll create a product that everyone can enjoy and benefit from. Spark 6. The importance of user feedback. As mentioned before, just like painters have to please an audience, hackers need to please a user. This means that when you start a company and begin designing your product, the end user has to be the most important thing in your mind. First, you should create and launch a prototype of your product as soon as possible to get feedback from real users. This strategy is called worse is better, because launching even a basic prototype early on gets you valuable feedback. This allows you to fix mistakes and improve the product to better suit your users' needs. A surprising example of this approach comes from the famous author Jane Austen. Before finalizing her books, she used to read them aloud to her family, who then made suggestions about what they would like to hear in the book. They were the first users for her prototype. If you succeed and make a product that matches users' needs and interests, they will probably want to buy it. Otherwise, they won't, no matter how many other sophisticated features it has. For example, if you were to design a chair, do you think anyone would buy it if it looked great but was horribly uncomfortable? Probably not. To gain users, you have to satisfy their needs, and the more users you have, the more successful your company will be. This is also a virtuous cycle. Users generate revenue, which you can then reinvest to make your product even better and get even more users. What's more, if someone is thinking about buying your company, they will value it based on the number of users you have. An app that has 100,000 users will have more potential buyers than an app with just 300 users. Spark 7. The diversity of programming languages. C++, Python, Java. You've probably sometimes heard programmers listing all the languages they can code in. What they're referring to are the programming languages in which they can give commands to computers. But computers don't actually understand these languages. They only comprehend machine language, meaning specific combinations of ones and zeros that tell the computer what functions to perform. This means programmers also need a compiler to translate the programming language into machine language. This sounds reasonable, but it might make you wonder, why do we need so many different programming languages? The reason is simply that different programming languages are good for different kinds of tasks. Just like with spoken languages, it can be easier to express certain things in one language than in another. For example, if you want to tell your computer to add variable y to variable x, you can do it in 2 lines of code in the language Lisp, whereas you'd need 4 lines in the language Perl. Sometimes the necessary concepts for your program don't even exist in the language you've chosen, so you have to either switch or find a workaround in the first language. For example, if you tried to add y to x in the language Python, you'd run into trouble because it doesn't fully recognize variables like that. So you'd have to find a workaround, which in this case would mean writing 6 lines of code. This is why there are so many languages in existence. But the field is far from static. Existing languages are constantly evolving and new ones are being developed. This is because languages are developed by programmers who adapt them according to their own preferences and requirements. Until the 1980s, this wasn't possible, since programming languages were developed only by institutions and large companies. These days, anyone can afford the necessary technology to adapt and develop current programming languages, or even come up with new ones. Spark 8. The aesthetics of programming languages. If you were to look at 1,000 paintings and divide the good from the bad, you'd obviously make that judgment based on your own taste. The same is true for hackers who decide between good and bad programming languages. They appreciate good taste in the programming languages they use, and as they advance as programmers, their own taste changes and develops too. For example, if you've designed your own programming language and years later publish a new version, it will surely be better than the previous one. This is because you didn't have the skills to make the original version as good as the updated one, and your taste has also improved along the way. So what's a good programming language? One that caters to a hacker's needs. For example, if a language is too complicated or limiting, hackers will simply use another one. If, however, a language meets the needs of hackers, it will become popular, which means they will embrace it and develop it further to perfect it. So good languages will inevitably get better over time, as hackers voluntarily work on finding and fixing bugs in it. Good examples of this dynamic can be found in open-source languages such as Perl and Python, which were privately designed by individuals but later released to the public so anyone and everyone could change and improve them. In general, businesses prefer using popular, widespread languages. This is because a program written in a commonly used language will likely be compatible with many other programs written in that same language. Another reason is that it's easier for companies to find and recruit programmers who code in popular languages. Despite these arguments in favor of popular languages, there are certain downsides, too. Since certain programming languages are optimized for certain tasks, forcing programmers to use a popular language for everything means you're possibly not getting the best performance from your product. Most likely, your competitors have this same problem. So if you were to switch to a more optimal language, you could gain a significant edge. What's more, your competitors could no longer analyze your position based on their own, since your products would be based on completely different technical platforms. This is what Graham did when he created ViaWeb with the little-known language Lisp, giving him a technical advantage and leaving his competitors wondering what exactly he was doing. Spark 9. Practical applications. Tackling spam. It was mentioned earlier that a good hacker can do virtually anything. One fun example is tackling a problem you're probably all too familiar with. Spam, the seemingly unstoppable flow of unsolicited advertisements that flood your inbox. So if you're a hacker sick of spam, how would you deal with it? You'd probably come up with a few different methods. First, you could approach the problem by looking at the individual properties of spam emails. For example, many spam emails begin with something like, "Dear friend." So you could write a piece of code that automatically puts all messages starting with this phrase in your spam folder. Second, you could employ statistical filtering, whereby every word in an incoming email would be analyzed, with the computer calculating the probability of the message being spam. Then the computer would put the likely offenders in your spam folder. Perhaps the best option, however, would be to personalize this statistical approach, saving certain messages from the spam folder even if the statistics indicated they might be spam. For example, Graham decreed any messages with the word Lisp as non-spam, as the word was included in many legitimate emails about the programming language. He also decided that messages from the addresses he had corresponded with were safe. But if you're a good hacker, you will also consider the consequences of your actions. In this case, by stopping spam, you risk also missing some important emails, because spam filters are never 100% accurate and can easily intercept legitimate mail too. So you'll probably have to sift through your spam folder every now and then to check for legitimate messages, but afterwards you can always improve your spam filter to not make the same mistake again. So while spam can be extremely irritating, trying to filter out all spam can also bring its own problems. In conclusion, Hackers and Painters provides a unique perspective on the world of programming and startups. Graham argues that programming is a creative endeavor, more akin to art than to traditional engineering. He highlights the rebellious nature of hackers and how this quality drives innovation. The book also offers practical advice for programmers considering launching their own startups, emphasizing the potential for wealth creation and the importance of user-centered design. Graham's insights into programming languages reveal the complexity and artistry involved in coding. He explains why different languages exist and how they evolve, driven by the needs and tastes of the hacker community. Finally, he demonstrates how hacking skills can be applied to everyday problems like spam, showcasing the practical power of programming. Throughout the book, Graham challenges conventional wisdom about nerds, wealth creation, and the nature of programming work. His arguments encourage readers to reconsider their assumptions about the tech world and to appreciate the creative, rebellious spirit that drives progress in the field of computer science.